Hello again, my cherubs. Today's video is on functions and relations. In this first picture, you will see the definition of a function. You have an input, which is your x value, your function x as the machine, and your output is the f of x, or y. So the first thing we're going to look at is the difference between a relation and a function. So a relation in general is just a set of ordered pairs, something we come across a lot in Algebra 2. Within that set of ordered pairs, you have a domain and a range. Your domain is your set of all x values, so 2, -1, 4, 9, and 0, and your range is all your y values in the set, 3, 5, -2, 9, and -6. In this mapping diagram, which I'll explain what that is a little later on, you will see that they put the x values, or the domain, in the first circle, and the range values, or the y values, in the second circle, and then connected the lines between the values. In this, you will see we are talking about functions. The difference between a function and a relation is in a function, your x only goes to one y. What that means is in this mapping, you will see that each x value in the green circle only has one line coming out of it to a y value in the blue circle. So to remember a function, in order to be a function, you cannot repeat your x's. That's a good life lesson, ladies and gentlemen, too. You should never repeat your x's. So again, a relation can repeat x's, a function does not. Okay, there is only one line coming out of each x value. So you'll see in this example, there are two lines coming out of the 2, so that is not a function. It still is a relation, but not a function. In this example, every x value only has one line, but you'll see there is nothing coming out of the 3, so that is also not a function. This is an example of a function because, again, every x value in the green goes to one value in the y. And you can ignore this slide for now. Next, we will look at the 3 ways that you can display a function. A function can be displayed as a set of tables where you have an input and an output, or an x and a y. It can be shown as mapping, where we put the x's in the first circle, y's in the second circle, and then connect them with a line. Or it can be shown with a graph, and in a graph you are looking to make sure that it passes the vertical line test, which I will explain here shortly. The next question is, how do I decide whether it is a function or not? If they provide it to you as a set of ordered pairs like you see here, you look at the x values to make sure that the x values do not repeat. If you look at number 7, you will see that your x values are 8, -3, -9, 15, -1, and -9. You repeat the -9 twice, so that therefore is not a function. Whereas in number 7, your x values are 5, -2, 0, 12, -40, and -5. None of those values repeat, so that is a function. The other way you can tell is if they give it to you as a graph, you do what is called the vertical line test. So you take your finger or a pencil and you go straight across from left to right, and if you can go across without touching the line in more than one place at the same time, then you have a function. If you hit 2 places at the same time, then that is not a function. So for example, in number 10, if I use a pencil or my finger and go from left to right, I am only ever going to hit the line at one place at a time. So that is a function. Where number 14, I'm going to hit multiple points on that circle at the same time, so that is not a function. The last thing we're going to look at is how do you create a function when given data. Keep in mind that when you represent a function, you can do it in one of 3 ways. You can do it through a table, through mapping, or through a graph. We will now look at how to represent a function all 3 ways using the ordered pair 0, 5, 1, 5, 2, 6, 3, 8, and 4, 9. So the first thing we'll do is look at creating a table. So you draw the table. The left side is your x values, the right side is your y values, and you just write your ordered pairs down. So 0, 5, 1, 5, 2, 6, 3, 8, and 4, 9. To represent a function in the form of mapping, you will draw two circles. Well, ovals really. In the left oval, you'll put in your x values, so 0, 1, 2, 3, and 4. On the right circle, you will put your y values, or your range, so 5, 6, 8, and 9. Notice I did not repeat the 5 twice. Then you will draw lines from your x values to your y values. So 0, 5, 1, 5, 2, 6, 3, 8, and 4, 9. The final way that you can represent is by creating a graph. And when creating the graph, you will draw a coordinate plane. So unlike scatter plots, you need the full graph this time. You may slightly skew it depending upon your data. And then you graph the ordered pairs. So 0, 5, 1, 5, 2, 6, 3, 8, and 4, 9. And I gotta fix my mistake here because I went up too far with the 1. Miss Lippert needs to learn how to count. Once you've graphed all your ordered pairs, you're going to connect your dots. You'll notice it does not make a straight line, and that is okay. This is one time where Miss Lippert can draw a line and it doesn't have to be straight. And in order to determine whether it is a function or not, you just look to see if you repeated your x's, and in this case we did not, so it is a function. The last thing I want to briefly look at is function notation, and we'll come back to this right before the keystone. So function notation is basically plug and chug. So they will use f of x, g of x, or h of x at the beginning of an equation, and what it does is that's kind of like a fancy way to say y equals. Okay, so you're going to see something like f of x equals 2x squared minus 3x plus 6. So the f stands for function, and the x is representing what you would plug in for x on the right-hand side. And an example of this would be on the following slide. So you will see that they wanted to know f of 2. So everywhere there's an x in the original equation, they plug in a 2, and then they solve, and they get the answer of 8. So f of 2 equals 8. And again, f of x is just a fancy way to say y equals. Here's another example where they wanted to find f of negative 2. And again, you won't have an assignment with this, but you will see it on the keystone. So when it gets closer to the keystone, we will come back to this, but I just wanted you to be familiar that it does connect back to functions. Okay, ladies and gentlemen, I hope you're having so much fun learning about functions. So let me wrap it up by a little quick review. So a relation is a set of ordered pairs where the x can repeat. A function is still a relation, but the x's can't repeat. Life lesson again, remember? Secondly, we looked at the 3 ways that you can represent a function. You can represent it in a table, where you just list your x and y's. You can represent it in mapping, where your x values go in the left circle, your y values go in the range, and you connect the numbers. Or you can represent it as a graph. To determine if it's a function or not, if they give it to you as an ordered pair, a table, or mapping, you look at the x values and make sure that the x values do not repeat. If they give it to you as a graph, you do what is the vertical line test. That's using your pencil, straight edge, your finger, and going from left to right on the graph and making sure that you only hit one spot on the line at a time. When creating a function, you can take the ordered pairs and you can put them in a table where you put the x values on the left, y values on the right. You can create a mapping diagram doing the same thing, x values in the left circle, y values in the right circle, and draw lines to connect your values from your ordered pair, or you can graph it. So again, those are the three ways. And then I concluded with a little brief overview of function notation. Don't get too worried about that. We'll come back to that before the keystones. Thank you for listening to my lovely voice as I depart my knowledge of functions and relations to you. I will see you very soon.